Course 3, Industrial Processing, Operational and Financial Management in Food Processing, Training on Startup Finance. Before we enter the technical content, this module focuses on operational and financial management in food processing, emphasizing the relationship between operational efficiency, cost control, and financial sustainability. Food processing enterprises operate under strict regulatory requirements, high resource use, and narrow margins, making efficiency and sound financial decision-making essential for competitiveness and resilience. The module introduces key concepts related to food production workflows, common sources of inefficiency, and practical tools for analyzing and improving operations. It also addresses startup finance in the food sector, exploring financing needs, funding options, and basic financial planning. Particular attention is given to economic flexibility and financial risk management, highlighting how efficient operations and waste reduction contribute to profitability, liquidity, and business resilience. Applied examples and practical exercises support learners in linking operational decisions with financial outcomes, promoting informed, data-driven management in food processing startups and small enterprises. In Submodule 2, we introduce how financial choices influence operational performance in food startups. Due to the need for certified facilities and specialized equipment, financing becomes directly tied to efficiency, waste reduction, and competitiveness. This slide explains how financial health translates directly into operational capabilities. Scientific studies on manufacturing SMEs show that startups with sufficient early-stage financing are much more able to invest in process optimization. Concretely, adequate finance allows firms to automate repetitive tasks, implement preventive maintenance systems, adopt lean manufacturing practices, and strengthen process control. These investments reduce waste levels, lower production variability, stabilize throughput, and improve resource consumption per unit. By contrast, when capital is scarce, startups are forced to keep manual, labor-intensive workflows and work with outdated equipment. That tends to make processes slower, more variable, and more waste-intensive. These weaknesses become particularly visible once commercial demand increases and the firm tries to scale. So, financing choices are a key determinant of both operational efficiency and scalability potential in food processing. Here we organize the financing needs of a food processing startup into 3 interdependent categories. First, capital expenditure or CAPEX, which includes investments in machinery, infrastructure, and layout. These decisions define the physical capacity and technical capability of the plant. Second, operating expenditure or OPEX, covering ingredients, packaging, utilities, labor, and testing. OPEX reflects how efficiently the daily operations are managed. Third, working capital, which is the liquidity needed to keep production running when payments from customers are delayed or when inputs are seasonal. These 3 dimensions interact. Underinvestment in CAPEX creates bottlenecks and process variability. Inadequate OPEX budgets often lead to rework, poor scheduling, and quality issues. Insufficient working capital causes production interruptions, longer lead times, and inventory waste. Together, they shape waste levels, unit economics, and the startup's ability to scale. In a food processing startup, CAPEX covers long-term investments such as processing lines, mixers, cookers, pasteurizers, filling machines, cold storage, and controlled environments, packaging equipment, cleaning and sanitation systems like CIP, and layout modifications that support hygienic flow. These investments determine the level of automation, process control, and throughput capacity that the startup can achieve. Research shows that early underinvestment in equipment capacity or layout quality often leads to bottlenecks, increased waste, unplanned downtime, and higher labor intensity because people have to compensate for technical limitations. In practice, CAPEX choices directly influence throughput, process stability, labor intensity, equipment utilization, and maintenance needs. Getting CAPEX wrong at the beginning can lock the firm into structurally inefficient operations. We now move from CAPEX to operating expenditure, or OPEX. OPEX represents the ongoing cost of daily operations in a food processing startup. It includes raw materials and ingredients, packaging materials, utilities such as energy, water, steam, and compressed air, direct labor, and all quality control and laboratory testing activities. Process inefficiencies increase OPEX through mechanisms like long setup times, repeated rework, poor scheduling, high changeover frequency, and inconsistent batch performance. Each of these issues consumes more material, more energy, and more labor, which directly raises variable costs and reduces contribution margins. When working capital is tight, startups often compensate by overproducing to reduce changeovers, building excess inventory, or postponing maintenance. These behaviors typically backfire by increasing storage costs, spoilage risk, and equipment failure rates. So OPEX is not just an accounting category, it is a mirror of how well processes are designed and managed. Working capital is needed because startups face cash flow gaps. Retailers often impose long payment terms, raw materials may be seasonal, and both raw and finished goods carry spoilage risk. Studies on manufacturing SMEs show that firms with constrained working capital experience longer lead times, higher waste, and reduced responsiveness to market needs. In practice, they struggle to purchase inputs on time, maintain stable production schedules, or buffer variability in demand and supply. Typical working capital pressures include payment term asymmetry, the perishability of products, inventory carrying costs, spoilage and obsolescence, and the need to hold safety stock. Managing these pressures well is essential to avoid production interruptions and to maintain service levels without generating unnecessary waste. Different financing instruments support different degrees of operational flexibility and process optimization capability. Each option carries implications for cost structure, decision-making freedom, and the ability to invest in efficiency-enhancing solutions. So we are going to talk about bootstrapping, bank loans and microfinance, equity financing, grants and public funding, crowdfunding, and financing constraints scaling in food processing startups. Bootstrapping, using personal savings, internal cash flow, or unpaid founder labor, is common in the early concept and prototyping phase. Advantages of this are full control over operational decisions, encourages lean, frugal, and waste-conscious practices, and no debt obligations. On the other hand, the limitations are restricted capacity to invest in efficient equipment, higher risk of process inefficiency due to underinvestment, and limited ability to scale or reduce unit costs. Scientific reviews note that excessive reliance on bootstrapping leads to capacity constraints and systemic inefficiencies that raise long-term costs. Here we look at bank loans and microfinance, the classic debt-based instruments. In food startups, debt is often used to finance CAPEX, such as processing equipment, or to support working capital. The main advantages are that it preserves ownership, it is well-suited for funding efficiency-improving machinery, and it offers predictable repayment schedules. On the downside, banks frequently perceive food startups as high risk due to limited track record and capital intensity. Collateral requirements can be high, and repayment obligations may put pressure on cash flow, particularly when retailer payment terms are long. Empirical studies show that guaranteed loans and public-backed credit schemes significantly increase SMEs' likelihood of investing in operational optimization, leading to lower OPEX and defect rates over time. Debt financing can therefore be a powerful enabler of process improvement if repayment profiles are compatible with the startup's cash generation and learning curve. This slide focuses on equity financing, which includes angel investors, venture capital, and strategic investors. Equity provides both capital and expertise, making it attractive for food ventures that require technological optimization. Unlike debt, equity does not require fixed repayments. which offers greater cash flow flexibility during early operational learning. Equity investors may also provide valuable industry knowledge, contacts with distributors or retailers, and support in regulatory or compliance pathways. However, equity implies ownership dilution and may introduce scaling pressure before processes are fully stabilized. If operational systems are still manual or waste-intensive, premature scaling increases both operational and financial risk. Equity is therefore most effective when the startup needs advanced optimization technologies, such as precision dosing systems, automated packaging, or digital quality monitoring, and when external expertise accelerates commercial growth. On this slide, we examine grants and public funding, which are particularly relevant for food startups because they are non-dilutive. Grants are ideal for funding process optimization, energy efficiency, waste reduction, and upgrades that support compliance maturity. Beyond a financial injection, grants increase credibility with other financiers, including banks and investors. Certificated facilities and documented quality systems reduce perceived operational risk and improve eligibility for co-financing. However, grants come with competitive application processes, reporting obligations, and administrative workload, which require planning and managerial capacity. Scientific studies show that grants accelerate SMEs' adoption of lean and green technologies, directly reducing waste and improving cost efficiency. For these reasons, grants are often one of the most effective funding instruments for early food process optimization. This slide introduces crowdfunding, which is increasingly used in the food and beverage sector. Crowdfunding provides market validation through pre-orders, builds community engagement, and allows flexible funding amounts. It is especially suitable for consumer-facing startups launching new product lines or sustainability-oriented offerings. While crowdfunding typically does not finance large-scale process automation, it can indirectly support OPEX and working capital during product launch. However, success depends heavily on marketing capability, and campaign outcomes are uncertain. If the campaign succeeds, fulfillment commitments create operational pressure, especially if processes are still manual or unstable. Overall, crowdfunding functions more as a market validation and liquidity support mechanism than as a major optimization funding vehicle. This slide explains how financing constraints shape scaling in food processing. Unlike digital ventures, food production scales through discrete capacity increases driven by equipment, cold storage, and skilled labor, requiring upfront investment. Financially constrained startups often rely on semi-manual processes and inefficient layouts, leading to bottlenecks, higher labor intensity, waste, and variable costs. Because inputs are perishable, operational inefficiencies quickly translate into losses and inconsistent service. Early underinvestment can lock firms into inefficient cost structures that are difficult to reverse. Effective scaling therefore depends on access to capital to support appropriate equipment, layout design, automation, and process improvements, making scaling both a financial and operational challenge. This slide introduces the bidirectional relationship between financing and operational efficiency. When financing is insufficient, startups are forced to work with outdated or inadequate equipment. This increases downtime, rework, scrap, and labor intensity, all of which elevate unit costs. With adequate financing, startups can invest in automated or semi-automated equipment, which reduces lead times, decreases waste, and strengthens product consistency. Scientific literature on manufacturing efficiency shows that financial capacity enables operational excellence, and operational excellence strengthens financial sustainability, creating a reinforcing cycle. This relationship is key to understanding why financing decisions are not just administrative. They shape waste levels, unit economics, and scalability. This slide reframes regulatory compliance not as a cost burden, but as a catalyst for operational discipline and financial resilience. Systems such as HACCP, traceability, allergen control, and hygiene zoning impose structured production practices that reduce variability and lower the probability of failures that cause waste, recalls, or reputational damage. Compliance frameworks also generate valuable data through testing, documentation, and traceability records. This data reveals patterns in yield, defect rates, batch variability, and equipment performance, which supports continuous improvement and lean decision-making. In this sense, compliance contributes to efficiency, waste reduction, and financial stability, in addition to ensuring food safety. This slide continues the compliance discussion from a financial perspective. Compliance increases credibility with lenders and investors because certificated facilities and documented systems reduce perceived operational risk. Grants supporting innovation, sustainability, or rural development often prioritize ventures with stronger compliance maturity, enabling them to finance efficient equipment, energy optimization, and waste reduction. Conversely, compliance failures trigger recall expenses, disposal costs, lost sales, and reputational damage, all of which are particularly destructive for cash-constrained startups. Compliance therefore stabilizes production, improves unit economics, and strengthens financing access. This slide introduces financial planning as a foundational capability in food processing ventures. Because food production is resource-intensive, financial decisions directly affect efficiency, waste, and cost competitiveness. Evidence shows that startups with structured financial planning achieve higher survival rates, stronger cost control, and better operational decision-making. Financial planning enables cost forecasting, cash flow monitoring, and assessment of the financial impact of inefficiencies and bottlenecks. In the food sector, where perishability and compliance create high fixed costs, weak financial planning leads to spoilage, disruptions, and liquidity stress. Effective financial planning aligns operational optimization with investment decisions, supporting waste reduction, production stability, and improved financial performance. The cost structure of food processing startups is typically divided into fixed and variable components. Understanding this classification is essential for analyzing unit economics, planning for different production volumes, and assessing how efficiency improvements affect financial performance. In food processing, cost structures are particularly sensitive due to high input costs, equipment and compliance requirements, and the perishability of raw materials. Because of these characteristics, inefficiencies directly raise cost per unit and reduce contribution margins. Cost structure analysis therefore provides the financial basis for optimization and scaling decisions. This slide focuses on fixed costs, which do not vary with production volume. Examples include rent or mortgage, equipment depreciation, salaried personnel, insurance, certifications, and baseline utility expenses. High fixed costs are common in food processing due to equipment and compliance requirements. Because fixed costs must be absorbed across production volume, low throughput results in higher unit cost, while increased throughput spreads fixed costs and strengthens competitiveness. This relationship explains why food processing businesses face strong pressure to optimize throughput and minimize downtime. This slide addresses variable costs, which increase with production volume. Examples include raw materials and ingredients, packaging, hourly labor, batch-specific utilities, cleaning cycles, sanitizing agents, and laboratory tests. Operational inefficiencies, such as waste, rework, inaccurate dosing, or long cleaning times, increase variable costs and reduce contribution margins. Higher variable costs raise the break-even point, making it harder for the startup to reach financial viability, especially during early market development. This slide distinguishes between CapEx and OpEx, two categories with different implications for efficiency. CapEx refers to long-term investments in productive assets such as machinery, packaging equipment, and facilities. CapEx enables automation, consistency, waste reduction, and higher throughput. OpEx reflects daily operating performance, including energy use, labor efficiency, material consumption, and maintenance. Understanding how CAPEX and OPEX interact is essential for assessing return on investment, financing options, and process optimization strategies. This slide distinguishes between CAPEX and OPEX and their different implications for operational efficiency. CAPEX refers to long-term investments in assets such as machinery, packaging equipment, production lines, cold storage, and hygienic facilities, enabling automation, waste reduction, process stability, and higher throughput. Underinvestment in CAPEX leads to bottlenecks, downtime, variability, and higher unit costs, limiting scalability and competitiveness. OPEX reflects daily operating performance, including labor, energy, water, maintenance, and waste. Effective process optimization, such as yield improvement, standardized work, better scheduling, shorter changeovers, and preventive maintenance, reduces OPEX and supports long-term financial sustainability. This slide introduces break-even analysis, which determines the minimum production volume needed to cover all costs. The formula is break-even volume, + fixed costs, selling price, variable cost per unit. Break-even is particularly important in food processing because fixed costs are often high, margins are thin, and inefficiencies increase variable costs. In this way, break-even creates a bridge between operational efficiency and financial survival. This slide highlights the distinction between profitability and liquidity. In food startups, ingredients, packaging, and labor must often be paid upfront, while retailers pay 30 to 60 days after delivery. As a result, a startup may appear profitable on paper but still face liquidity failures due to cash flow timing. Cash flow management is therefore crucial for maintaining production continuity, preventing interruptions, and ensuring the startup can meet commercial demand. This slide examines cash inflows and outflows. In food processing, outflows occur early for ingredients, packaging, labor, utilities, and compliance expenses. Inflows depend on payment terms, sales channel structure, and negotiation power with retailers and distributors. Because retailers often pay 30 to 60 days after delivery while suppliers expect immediate payment, a structural timing gap emerges. This gap creates liquidity pressure even when sales are strong. Managing these timing differences is one of the core challenges of working capital in food startups, and it directly influences production continuity. This slide describes working capital challenges. Working capital is shaped by inventory levels, delayed customer payments, safety stock needs, and spoilage risk. Poor working capital management leads to production interruptions, delivery failures, overtime costs, and increased waste due to rushed or irregular scheduling. Because food products are perishable, startups require buffers to absorb variability, but these buffers tie up cash and increase refrigeration costs and spoilage risk. Effective working capital management is therefore a precondition for stable production and proves especially important during early scaling. This slide shows how payment terms influence production planning. When customers impose long payment terms and suppliers demand upfront payment, liquidity constraints shape batch sizing, scheduling, and inventory buffers. Startups under liquidity stress may run smaller batches to reduce raw material exposure, even when larger batches would reduce changeovers and increase throughput. Others may build excess finished goods inventory to protect against stockouts, increasing storage costs and spoilage risk. These dynamics demonstrate that financial constraints produce operational inefficiencies, including waste and higher lead times. This slide introduces financial risk management in food startups. Food ventures face higher financial exposure than many other industries due to perishability, compliance requirements, capital-intensive equipment, and the need for consistent product quality. Scientific studies show that many early-stage failures are not caused by poor products or weak demand, but by insufficient capitalization, unstable cash flow, and limited risk mitigation capability. Managing financial risk is therefore essential for protecting operational continuity and reducing waste. Now let's talk about key financial risks in food processing startups. In this chapter, we are going to learn about 5 points, which are undercapitalization, the most common risk, cash flow shortages, cost volatility, ingredients, energy, packaging, equipment failure and maintenance risks, and regulatory and compliance risks. This slide focuses on undercapitalization, the most common financial risk. Starting operations without sufficient capital prevents investment in equipment, restricts raw material purchasing, and slows scaling. Common causes include over-reliance on bootstrapping, underestimation of compliance costs, and lack of liquidity buffers. Research shows that undercapitalized firms experience greater operational instability and shorter survival times. This slide examines cash flow shortages, a high-risk condition in food processing. Due to long retailer payment terms and immediate supplier payments, liquidity can collapse even when the business is profitable on paper. Symptoms include postponed maintenance, delayed raw material purchases, and rushed production that increases rework and waste. Cash flow shortages therefore compromise both operational reliability and financial sustainability. This slide addresses cost volatility, particularly in ingredients, energy, and packaging. These inputs are exposed to climate variability, geopolitical instability, and supply chain shocks. Volatility compresses margins, complicates pricing, and makes production planning more uncertain. Startups are disproportionately exposed because they lack the negotiation power to secure long-term supply contracts. This slide examines equipment failure and maintenance risk, which, although operational in nature, carries strong financial implications. Equipment breakdowns create unplanned repair expenses, downtime, and waste generated during restart procedures. Startups with limited reserves cannot absorb these shocks, leading to prolonged shutdowns and lost orders. Maintenance practices range from reactive repair to preventive planning, and the latter reduces downtime, stabilizes throughput, and protects unit economics. This slide focuses on regulatory and compliance risk. Food businesses operate under strict regulatory oversight, and nonconformities with HACCP, labeling, traceability, or allergen standards may trigger recalls, disposal, penalties, and reputational damage. These failures carry immediate financial consequences and are especially dangerous for cash-constrained startups. Compliance maturity therefore serves not only a legal function, but also a financial risk mitigation function. This slide introduces the main practical mitigation strategies that food startups can use to manage financial and operational risks. The key message is that each risk area requires a targeted response that combines financial planning with operational control. We will look at how to mitigate undercapitalization, cash flow shortages, cost volatility, equipment-related risks, and regulatory risks. Together, these strategies help protect liquidity, maintain production stability, reduce waste, and ensure compliance with food safety requirements. In the next slide, we will go through each of these mitigation areas and explain the specific tools and decisions that support resilience and efficient performance. This section presents key mitigation strategies for food startups, highlighting the need to integrate financial and operational actions. Undercapitalization can be reduced by combining funding sources, phasing investments, limiting bootstrapping for CapEx, and using partnerships such as co-packers. Cash flow risk is managed through better payment terms, supplier credit, inventory control, and forecasting, while efficiency improvements help reduce variable costs. Cost volatility is addressed through supplier diversification, flexible formulations, margin monitoring, and energy efficiency. Equipment and regulatory risks are mitigated through preventive maintenance, leasing, financial buffers, staff training, audits, and early compliance support. This slide emphasizes that operational efficiency is a financial strategy. Reducing waste improves contribution margin. Stabilizing throughput spreads fixed costs, and efficiency strengthens cash flow and competitiveness. These characteristics also improve investor attractiveness by reducing perceived operational risk. This section explains how operational efficiency directly affects financial performance in food processing. With thin margins and high variable costs, even small reductions in waste, rework, or giveaway deliver large gains in contribution margin and profitability. Process stability is critical. Variability, changeovers, and stoppages reduce throughput and increase unit costs, while optimization improves capacity utilization and supports faster, more competitive scaling. Energy and utilities are major overhead drivers, and improvements in heating, cooling, water use, CIP, and equipment utilization reduce OPEX and strengthen cash flow resilience, especially in early-stage ventures. Unit economics are highly sensitive to yield and variability, affecting margins, break-even points, and pricing power. Sensitivity and scenario analysis help startups quantify the financial impact of improvements, often showing that investments in calibration, standardization, and preventive maintenance deliver strong returns while improving forecasting accuracy and financial resilience. This slide explains why waste reduction is both an operational and a financial sustainability strategy in food processing. Every unit of waste represents unrecoverable cost from raw materials, labor, energy, and disposal. Waste also lowers yield, increases variability, and raises the risk of quality issues reaching customers. Reducing waste lowers production cost per unit, improves product consistency, and supports better forecasting and planning. At the same time, it reduces environmental impact, strengthening brand value and meeting growing customer and investor expectations. In practice, waste control improves margins, stabilizes operations, and directly supports long-term financial sustainability. Thank you.